Hello everyone. Today I will be showing you an app I made for students and teachers in high school level math classes called Algebraic. This app involves 3 sub-apps: Statplot Creator, Lists, and Formulas. From any of these screens you can access a help menu which will take you to a page where you can see all of the different ways the 3 apps function and what you can use them for. When you exit, it will take you to Statplot Creator, but you can easily navigate back to any others. You can enter numbers for the start and end of an interval to randomly select numbers, how many numbers you'll select, the biggest number you want for them to count for percents, and how many times you're going to be running the simulation. Then, when you press the button, this will generate percents, or what you have selected in the settings, and it will also graph these from the left side to the right side under. You can also import these values into the lists function app, and you can take the average, and this will be, for this example, around 37, because around 37% of numbers from 1 to 100 are under 37. You can also take the least or the greatest, which will give you the said values based off of all the ones that you inputted, which can help with graphing and understanding where things are. You can also reset it and import new values. You can also use the standard deviation, which will first generate the average and then take that and go through the values to generate the standard deviation. The next app is Formulas, where you can input from either lists or the formulas answer itself, and then you can go through using all my different formulas, such as the Pythagorean formula taking 2 legs of a triangle, getting the hypotenuse, must be a right triangle, and you could also use the quadratic formula, of course. You can also use other formulas. There are many there, such as calculating an exponent, dividing, converting from radius to circumference or area, or using the reverse Pythagorean formula, which will go from the hypotenuse, subtracting, and will give you the remaining leg, with squaring, not just basic subtraction, of course. This also has sine, cosine, and tan, which you would find on an iPhone or graphing calculator. And you can see, if we plug in my remembrance of pi into this, it will become very close, if not equal to, by decimal places, the exact value of 0, because pi 0 is a point on the sine wave function. You can turn the decimal places you receive to whatever, but 3 is good for most cases, so it is the default. As you can see, there is also the other reverses of the function, whereas when you enter sine or cosine, it gives you between -1 and 1. Entering those into this will give you what you had before, going from angles to the value and back. You can also see that I've programmed in different growth formulas of exponential growth, where if you have $100 to start with and a 100% growth rate, and it gets compounded 12 times per year, so once a month, then this is what you will end up with, which you can put back into the growth formula using the top right import formulas answer, and you can see it grows by the same amount each time because the interest rate will not change. A more normal interest rate would be around 3%, but it will end up as slightly more than 3% more than the total, as each time you're taking 1/12 of 3% extra, but since you're doing it 12 times, each of those takes from what it had last time, which is why compounding makes a big deal depending on your interest rate. If you know what your interest rate divided by your compounding times per year is, and you also know how many times it will be compounded in your selected time, then you can just put in this directly and solve to get straight to your answer. Such as in this case, where if you start with $100 again, but not the emoji, and then you have an interest rate of 7.6%, which is not 76%, don't get it confused, and you want to interest compound it 1 time, 2 times, 3 times, you could continue on or do it 15 times at once from here, which is useful if, once again, you know everything about what you will be doing and you know how many times it will be compounded. Such as if you want it compounded twice, for example, or just once again, you can always know and calculate back and forth when it will be at different points in compounding, say January, February, March, all the way through December. You are also able to use the common logarithm, which is in base 10 of a, to tell what something is, how many times 10 will be multiplied to itself to get to that number, where 10 to the power of 3 is equal to 1,000, and e to the power of just 1 would be around 2.718. You can also pick any base of your own choosing, such as base 2, and 2 to the power of 3 would of course get you 8, and this will figure that out for you. One of the things I worked hardest on recently was being able to switch from different numbers of bases. You can have a number input like 16, which is in base 10, because that's how we count with 10 fingers, but you could put it into base 2 using only ones and zeros, how computers talk. And of course that would give you 10000, because there is a 1 in the 16's place, as the numbers go from right to left in the 1st, 2nd, 4th, and 8th and 16th place. Like numbers in base 10 go from 1, 10, 100, and 1000th places. But in base 2, rather than multiplying by 10 each time the digits go left or dividing to the right, it multiplies by just 2, which helps with computers in how they switch their diodes or something. I'm not a computer expert. On or off. They cannot store multiple states other than on or off to represent ones and zeros. You can also put in numbers in any other form, or if you want to go from 2000 in base 10 seconds, but you want to turn it into minutes, so you're doing it in base 60. Well, the digit to the right would be seconds, the digit after that would be the minutes, and the digit after that would be hours. Unfortunately, I have not coded to create a specific one that can convert with base 60 twice and then base 24 to go from hours to days. So at this point, it gets a little screwy, and you should not take the fourth digit as a days counter. As you can see right now, I'm clearing the percentage limit and putting it at 100. And all numbers between 1 and 100 are going to be less than or equal to 100. So they're all going to be 100%. So all of the little squares will move to the far right to clear your board if you're going to do any other ones with less values. Also, if you only take one value during each simulation, then your values will be spread out more because you have less consistency when you take less values. Whereas when you roll 100 times, you're probably going to get around 50 on average for them, and they're going to be the amount that you set it at for what their percents will usually be. But when you're only taking one, it's a wild guess whether it's going to be or not. And if you take 10, it's less wild, but still quite a wild guess to whether they will all be above or below or somewhere around there. You can also switch the form between the percent of them that are below, the average of all of them, or the total of all of them. But do not pick all of them and then try to put them in lists, because the answer you will get will combine everything into one data set and it will not work out. Here you can see when we have lots of values that are between 1 and 1,000, but we only take the averages, there are going to be some wild numbers like 323 and 676. But when we average them out, they all go around to 500, which is in no way related to this 500 here, which just says how many simulations you run total, how many commas will be in your list, where you can have 397 of them, and the answers you get will be around the same, but there will be 397 of them, not 500, and they will still average around to 500, as it is shown multiple times here with running the simulations, getting different numbers all the time, and the average always being around the same. Though since we only run 10 numbers each time, the single values were quite considerably far away from 500, which is shown by the standard deviation here, which shows how far away they are on average, but it's a bit more complicated than that. Of course, I have also added a way to access my YouTube channel directly through the app, which may be how some of you got here. And you can also tap him and he will give you some remarks. And there's also my website page, which takes you to my main source where I keep all my apps, where you can access them all at any time, which would be beneficial to you and me if you liked this video or the app. Thank you.